In the end of position reference equipment and sensor chapter, I would like to say a few words about inertial navigation. Please watch the subject movie about the idea of inertial navigation, and then we will give a few main comments connected with inertial navigation.
Since time immemorial, humankind has endeavored to journey.
Hello. As you say, yes, people have always tried to get from point A to point B. Over land, across seas, or more recently by air, and even into outer space. For a long time, the only way they could do all of that was using the stars to find their way. Inertial navigation is based on the same idea, without the stargazing. This type of navigation uses measurements of movement, starting with the Earth's rotation in relation to the stars, a bit like the pendulum that Foucault invented in the 19th century. A piece of wire and a bob hanging from one end. That's all physicist Léon Foucault needed to show that it's not the sky that turns around the Earth, but the Earth that spins on itself. Check this out. Following physical principles, a pendulum will always swing in the same direction in relation to the stars. But in practice, if we watch it for long enough, we can see that the pendulum appears to change direction after a while. This proves that the Earth is spinning on itself. But let's come back to navigation. On a submarine, for example, an inertial navigation system can calculate the underwater craft's position and course in space's 3 dimensions, using 6 movement sensors, 3 accelerometers, and 3 gyroscopes. So the 3 accelerometers measure translation, while the 3 gyroscopes measure rotation. All that information reaches a very powerful computer that figures out exactly where the submarine is. Unlike GPS receivers, which need to connect to satellites,
1.5 meters.
inertial navigation systems don't need to interact with other gizmos to know exactly where a plane is, for example, or even to know how much a plane is tilting. As you may know, all commercial aircraft have several onboard inertial systems. Inertial navigation systems are also vital for military vehicles because they're impossible to detect and entirely self-reliant. Today, using latest generation hemispherical resonator gyroscopes, also called HRGs, Safran managed to reproduce the Foucault pendulum effect with resonance on a small hemispherical shell made of silesia. You know, like a crystal glass. This has opened the door to designing miniature inertial systems, which are now on board all sorts of vehicles. Submarines, of course, but also boats, planes, autonomous land vehicles, space launchers, and even satellites, to keep them on their path in orbit. Unlike you and many other gyro technologies, HRGs don't suffer from aging process, so they will work just about forever, with no maintenance whatsoever. Inertial navigation is also helping to develop augmented reality in plane cockpits, for example. So in the future, these systems will be able to get from any point A to any point B perfectly safely, and won't even need a pilot. There, now you know everything, or nearly everything. Before we leave you, note that these calculations based on the immutable principles of physics make inertial navigation systems 100% reliable. Unless, of course, the Earth stopped spinning.
In deep water, long baseline acoustics suffer a number of problems. The travel time of the acoustic energy may mean a low update rate for the position, while poor acoustic conditions in the water may further reduce update rate. Under these conditions, the HPR system may become less reliable and accurate, A possible remedy for this problem is given by incorporating an inertial measurement unit and processor within the HPR system. On the market we have one name proposed by Konsbeck. The name is HAIN. It means Hydroacoustic Aided Inertial Navigation System. If you're interested about that, you can check the producer website and to find more details about the idea of HAIN.